Welcome back to the second part, or welcome to the second part of our discussion about the physical properties of unsaturated hydrocarbons and the chemical reactions, or the chemical properties, or the characteristics of the reactions that involves our unsaturated hydrocarbons, particularly our alkenes. Okay, so take note that take note that the physical properties of our unsaturated hydrocarbons includes number one, they are nonpolar. Okay, nonpolar because they only have carbon and hydrogen bonds. Okay, so they are nonpolar compounds. Next is the only attraction between their molecules is the London dispersion forces. Just almost the same thing as our alkanes, right? Next. Yan. Physical properties are similar to those of alkanes with the same carbon skeletons. Alkenes and alkynes are insoluble in water because of they are nonpolar compounds and because of they cannot form a hydrogen bond between the water because of weak forces, because of the London dispersion forces. No? But they are soluble in one another, or in nonpolar organic compounds. Okay, so almost the same thing as our alkenes, likes dissolves likes. And alkenes and alkynes are liquid, that are liquid or solid at room temperature. They have the density of less than 1 gram per ml. Therefore, they float on water. Guys, again, I will put the remember me. I will not sing anymore. Okay? I will not sing anymore, but I will write remember me. Okay? It is important for you to remember this one. All right. Now, how about the characteristic reactions of alkenes? Now, take note, guys, that alkenes may undergo many chemical reactions. Okay. Take note that most alkene reactions are exothermic. Okay. They are exothermic. Now, what do we mean when we said exothermic? It is capable to release heat. No? It is capable to release heat, exothermic. Okay? Now, the products are stable than the reactants. Okay? This is more stable, or this is stable than this one. Why? Why is this stable? This is stable because it has only one bond, unlike this one. Okay, next, not because they are exothermic, I want to take note of this, not because they are exothermic, it will means that it will have a rapid reaction. No, it doesn't. It does. It does not go that way. Goes that way. Take note. Even though that they are exothermic, they are capable to release heat. No, their reaction rate depends on the activation energy. Again, I want you to take note that even though that they are exothermic, it doesn't mean that alkene reaction occurs rapidly or mabilis. No, it does not go that way. No? The reaction rate depends on the activation energy. Okay? I will write here, even though that is written in your module, reaction rates, no? Reaction rates depends, layo ng depends, I'm sorry, depends on the activation energy. All right? And take note that most of the alkene reactions requires catalyst. Okay? Requires catalyst. Now, before I proceed to the reactions that involves or the reactions of alkenes, I will have first a review, or we will have first a review of the reaction of alkenes. A reactions of alkenes. Okay, guys, don't be confused, huh? This is just a review. I will write here, review. Yeah, this is just a review. Again, when we said reactions of alkenes, there are two. We have combustion, whoa, and we have the halogenation, or simply the substitution reaction. Oh, substitution reaction. Okay. We said that in combustion, no, we said that in combustion, okay, alkane plus oxygen, no, in the presence of heat, do we have? Okay, no, no, alkane plus oxygen, we don't have in the presence of heat because it is one of our product. Will give us carbon dioxide, water, and energy. This is the reason why alkanes are used as fuel, diesel, uh, as a source of energy in vehicles or aviation, okay, because it produces energy once that the alkanes reacts with oxygen. That is what we call combustion. Now, when we said halogenation or substitution, no, halogens replace or substitute, okay, substitute our hydrogen. Okay. Then it requires what? Heat or light. If we don't have heat, if we don't have light, there is no reaction. Example, so let's have an example. Um, okay, so we have propane plus chlorine. Yeah, chlorine. Yeah. So why we have to indicate two? This is diatomic. Okay, so we have Cl plus HCl. So this is one chloro. Ah, I spelled it wrong. One chloropropane. This can go further oxidation, or further halogenation, no? So it will give us 1,2 or 1,1, I'm sorry, 1,1 dichloropropane, okay? And so on and so forth. So these are the reactions that involves our alkanes. Now, we'll proceed to our main objective, our main topic, which are or which is the reactions of alkenes. Okay, so we have hydrochlorination, we have hydration, we have bromination, and we have hydrogenation. Okay, again, when we said hydrochlorination, this is actually now referred as the addition of HX or hydrohalogenation. Okay, hydrochlorination, or now referred as the addition of the HX, or also known as the hydrohalogenation. Okay, so we have the HX, so that will be HCl, HBr, or HF. Anything, or pwede yan. Okay, next for hydration, alkene plus water. Hydrate, hydration, water. Alkene plus water. Bromination, or simply, this is what we call halogenation. Okay? Alkene plus halogens and hydrogenation. Okay? Hydrogenation, reduction reaction. No? We have gain of hydrogen. So let's discuss each. Let's start with halogenation or hydro rather. hydrohalogenation, also known as the addition of HX. We have here an example, ethylene, no? The simplest alkene that we have, plus our HCl. Okay, so the double bonds will be removed because we have here the attachment of hydrogen and chlorine. Again, remember, this will be split into hydrogen and chlorine. Okay, so we have here your hydrogen attached to this carbon, and we have chlorine attached on this carbon, or either way, to give us chloroethane. But let's say, for example, no, let's say, for example, we have this one. Okay, what will be the product of this one? This is 1, 2, 3, 1 propene. If we are going to illustrate 1 propene, that will be 1, 2, 3. Well, basically this is just the same. I show this one, or I illustrate using this one so that you will be able to take note. What will I say? Plus HCl will give us what? Okay, this will give us what? This will give us uh, 2-chloro, okay, 1 propene. Okay, this will give us 2-chloro, 1 propene. Sir, I have question. Why 2-chloro, 1 propene? Okay, I will have a bigger screen so that I can write well. Our first example is we have H2 double bond CH2 plus HCl will give you CH3 to H2Cl. We name it as 1-chloro. We name it as 1-chloroethane, right? It as 1-chloroethane or chloroethane. Okay, it has 1-chloroethane or chloroethane or chloroethyl, ethyl chloride. Anything will do. This is the impact name. Now, the other example we have CH2, CH, CH3 plus HCl. So this will be 1, 1, 2, 3, 1, 1, 2 plus HCl. What will be the product? Now take note, guys, this shows a radioselective reaction. Okay, when we said radioselective, a reaction in which one direction of bond forming or bonds breaking occurs in the presence to all other directions. Okay? And this was noted by Vladimir Markovnikov. Okay? This was noted by Vladimir Markovnikov's question. Who is Vladimir Markovnikov? He is a scientist, no, who postulated the Markovnikov's rule. Markovnikov's rule. And what is stated in Markovnikov's rule? In Markovnikov's rule, we said that in addition of HX and H2O or water, to alkene, okay, to alkene, hydrogens, okay, hydrogens, okay, or hydrogen add to the carbon of double bond having the greatest number of hydrogens. I'm sorry. Having the greatest number of hydrogens. While the halogens or X or OH will bond on the carbon with lesser hydrogen. Okay? So then, when we said Markov-Jakov's rule, in addition of HX and H2O to alkene hydrogens, no, there's an emphasis hydrogens, add to the carbon of or hydrogen. Yeah, let's make it hydrogen lang. Hydrogens or hydrogen adds to a carbon of double bond having the greatest number of hydrogens, while halogens or X or OH, no, will bond on the carbon with the lesser hydrogen. Meaning to say, or in other words, to make it simple, hydrogen will attach to carbon, to carbon rich in hydrogen. X or OH will bond to carbon poor. In Tagalog, si hydrogen mag-a-attach sa carbon na mayaman sa hydrogen. Si X, yung X mo, si X at si OH, yung XO, si X at si OH will attach doon sa 4. Oh, have a mnemonic. Hydrogen will bond to carbon rich. Ang hydrogen sa mayaman na carbon. Mayaman sa hydrogen. Greater number of hydrogen. Yung X mo sa 4. Yung O sa 4. Yung X or yung OH sa 4. Yung H sa mayaman. Now, in this case, we have 1 propene plus HCl. Okay? 1 propene plus HCl. So this is our double bond. Okay? Question. Which is the carbon-rich hydrogen? This one. This is the hydrogen pool. So ibig sabihin, in this carbon we will have hydrogen, and in this carbon we will have our chlorine. Therefore, it will give us 1, 2, 3 Cl, and the rest are hydrogen. Okay, so the name is 2-chloropropane. Oh, sir, wait. Why propane? We only have one bond. Carbon-carbon single bonds. So ibig sabihin, sir, in hydrogenation, in halogenation, also known as the addition of HX, okay, we will form alkane. Yes, particularly haloalkane. Okay, because we remove the double bond, and this is a stable than this one. Okay. So let's have here an example. Draw the structural formula and the name of each alkene reaction. Okay? So we will name it accordingly and we will illustrate it accordingly. First is, let's name this one. This is our, where's my pen? Yeah. Uh, okay. So we have here 1, 2, 3. Okay. So 2 methyl, 1 propene plus HCl. So that will be, okay. So in this carbon, we will have the attachment of hydrogen, and in this carbon, we will have the attachment of iodine. Therefore, we will have it as this way. H, 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 I, no, H, 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 and CH. The name will be 2-iodo, 2-methyl A propane. Okay, so we have 2-iodo, 2-methyl propane. How about this one? Okay, this is our uh, 1-methyl cyclopentene plus HCl. So that will be this way. Wait, I will show the condensed one. Okay, 1, 2, 3, 4. 1, 2, 3. This is hydrogen here. We have here hydrogen, 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 hydrogen. Okay, so this is the carbon rich in hydrogen. Okay, so that will be hydrogen, 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 another hydrogen. So we have here hydrogen also, this one, CH3, and this one will have the attachment of fluorine. Therefore, the structure will be like this. So the name is 1-chloro, 1-methyl cyclopentane. Okay, 1-chloro, 1-methyl cyclopentane. Now, how about this one? 1-propene. So propane, 1, 2, 3. Okay, this is actually the same thing as what we had in our example a while ago. Okay, so this is the carbon rich in hydrogen. So this is the carbon where our hydrogen will attach. So that's basically Br, and this will have the rest of the carbon, hydrogens rather. Okay, so we have 2-bromopropane. Okay? Now, how the reaction occurs. Now, I want you to take note of this. Number one, pattern number one, addition of a proton. Okay? Remember, an acid is a proton donor. A base is a proton acceptor. Use curve to show the arrows how a proton transfer occurs. So again, this is our acid. No? This is a proton donor. This is a proton acceptor. Next, take the proton away. If we run the reaction in reverse, it corresponds of taking a proton away. If we are going to get the proton going to this one, then that is a proton away, taking the proton away. Okay? Because remember, your hydrogen can only have 3 bonds, but still, meron siyang 1 covalent or 1 electron, or that's for pairing. No? So yan. Next we have pattern number 3. Reaction of electrophile and nucleophile. Now, what do we mean by electrophile? Okay? When we said electrophile, that is actually an electron-poor species that accepts a pair of electrons from a new to form a new covalent bond. When we said nucleophile, electron-rich species that can be that can donate a pair of electrons to form a new covalent bond. So this is what we have in our examples. No, we have the electrophile and the nucleophile. Again, when we said electrophile, that is the carbon poor, electron poor, meaning to say it needs electron. Nucleophile, electron rich. So since this one used, no, this one used the double bonds, carbon-carbon double bonds. Okay, meaning to say this will be our electrophile. Our carbon here is our electrophile. This is electron poor. Kailangan niya ng electron rich, so that is our chloride. In our example a while ago, okay, this one used the double bond. Since this one used the double bond, it will have a partially positive charge. A partially positive charge indicates that that is a electrophile, which is poor in electron. Therefore, we have here an electron-rich species, no? Then will be attached to this one to form our alkane. Okay? Pattern number 4, reaction of proton donor with a carbon-carbon double bonds to form a new covalent bonds. Okay? The double bonds provides both of the electrons or both of electrons that form a new covalent bond. In the following reaction, show the hydronium ion as a proton donor. Okay? While the above equation is the most accurate way to show the proton transfer, we will simplify the equation just to show proton and the formation of a new covalent bond like this. Okay. So that is how the reaction occurs. Now we have here the addition of water. We're almost done. No? We are near the end of this video discussion or lecture. So we have ethylene plus water. Now remember guys, in addition of water, also known as hydration, okay, this is addition of water, also known as hydration. Okay, this is a acid catalyzed reaction. Acid catalyzed reaction. Ibig sabihin, we need an acid catalyst so that this reaction will occur. Again, this requires an acid catalyst. And the most commonly acid catalyst, or the most common acid catalyst, is the sulfuric acid. Okay? Again, in the addition of water, no, it requires an acid catalyst, and the most common catalyst that we have is the sulfuric acid. Okay? Again, take note that addition of water or hydration follows the Markov-Nikols's rule. Okay? It follows the Markov-Nikols's rule. Okay. So we have here ethylene plus water. So that is ethylene plus water. I will write here. I will delete everything. Number one, I will write here. Number one, we have ethylene plus water in the presence of sulfuric acid. Take note, guys, that this water will split into hydrogen and OH. Okay? So again, the carbon rich and the carbon poor. So we have OH, H, 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 H. Okay? So this is now our product, or simply this one. Okay? This is now our ethanol. Okay? Since we have hydroxide or OH, we have it as ethanol. Now, how about this one? Propene or 1-propene. So that will be 1, 2, 3, hydrogen, hydrogen number 2, hydrogen, 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 hydrogen. Okay? So, plus water in the presence of sulfuric acid, we have 1, 2. We have here the OH, no, and the rest is your hydrogen, 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 hydrogen. This is now our 2-propanol. Okay? 2-propanol is also known as your isopropyl alcohol. Okay? Now, in other words, addition of alcohol in the presence of sulfuric acid as an acid catalyst will give you what? Alcohol. Okay? Addition of water and alkene. Alkene plus water, or alkene, this is our conclusion, alkene plus water in the presence of sulfuric acid as an acid catalyst will give us alcohol. Okay? Now, how about this one? 2-methylpropene. This is our CH. Yeah, this is our 2-methylpropene plus water. So this is number 3. Will give us what? OH3. I'm sorry, CH3. Okay? This will give us what? This will give us 2-methyl 2-propanol. Okay? 2-methyl 2-propanol. All right. How about this one? Number 4. For number 4, we have 1-methylcyclohexene. So that will be I will make it better for you. Okay, so this will be H2SO4. So that will be this way. H3. So this is now our 1 methyl 1 cyclohexanol. Cyclohexanol. Okay. 1 methyl 1 cyclohexanol. Now, how about this one? 2 methyl 2 butene. So number 5. 1, 2. Yeah. So we have 2 methyl 2 butene plus water will give us 1, 2, 3. Okay. Will give us, here is our CH3. Here is our OH. Therefore, we have it as 2 methyl 2 butanol. Okay. So that is how we name our addition of HX. Now, how about for halogenation? Now, for halogenation, take note that this reaction occurs at a room temperature. Room temperature, okay, this occurs in a room temperature, no, and requires catalyst, no, and the catalyst or solvent catalyst is our dichloromethane. Dichloromethane, okay, CH2Cl, okay. That is our dichloromethane. Okay, we have here 2-butene. So 2-butene is like this. Yeah, that's HBr. So again, the hydrogens will be replaced by bromine. So this will give us 1, 2, 3 Br. So we have 2, 3 dibromobutane. How about this one? Cyclohexene. Okay, so it will be like this. Br, Br. 1, 2 dichloro, dibromo pala, I'm sorry. Dibromo, dibromo cyclohexane. Okay. Now, how about this one? Please try 1 methyl cyclohexane plus Cl2 and cyclopentene plus chlorine. Okay. I want you to try that one. 1 methyl cyclohexane and cyclopentene. All right, how are we going to have that? So that is cyclohexane. So let's do first cyclohexane. So that will be this way. Okay. So how are we going to name this? 1,2-dichloro 1-methyl cyclohexane. All right, how about this one? Cyclopentene. Just cyclopentene. Okay, so we have 1,2-dichlorocyclopentane. Okay, so that is our halogenation. Now, how about for the addition of hydrogen? Now, take note, guys. In addition of hydrogen, this is also known as hydrogenation. No, this requires, okay, it requires metallic or metal or transition metal catalyst. Okay, so what are those? We have number one, platinum. It can be palladium. It can be ruthenium, or it can be nickel. Okay, again, it requires transition metal catalyst. So either of the four may be our catalyst. Next, it involves the reaction of hydrogen. Okay, since this involves the reaction of hydrogen in the presence of our metal catalyst, this is what we call catalytic reactions. Okay, this is what we call catalytic catalytic reactions or catalytic catalytic reduction. Okay? Why we name catalytic reduction? Because there is an involvement of transition metal catalyst. Okay? The reaction is carried out by dissolving the alkene. So we have to dissolve the alkene in organic solvents or in ethanol, no? And then expose it into hydrogen at at pressure ranging from the pressure atmospheric pressure ranging from 1 to 150 atmosphere. Okay, so let's have an example here. I will delete everything that I have here. So we have here 1, 2, 3, 4. This is our 2-butene plus water or hydrogen in the presence of our transition metal catalyst at 25 degrees Celsius. Take note that it occurs in a room temperature at 3 atmospheric pressure. So that will be this way. We remove the double bond, and since this has a partial positive charge, a negative charge rather, this has a partial negative charge, so this one will attach to it. So instead of having a double bond, we have our single bond. So 1, 2, 3, 4. This is now our butane. Okay, how about this one? Again, this is also the same thing. We will remove the double bond and we will be able to form our cyclohexane. Okay, so that is how we have our addition of hydrogen. Again, it requires transition metal catalyst. It can be platinum, palladium, ruthenium, or nickel. Either of the four can be the catalyst. The reaction occurs, the reaction requires exposure to pressure from 1 to 150 atmospheric pressure, and the alkene must be dissolved in organic solvent or ethanol, okay, so that there will be a reaction and the mixture will be exposed to hydrogen gas. Again, the product of the addition of hydrogen or hydrogenation is what we call alkane. Okay, so again, save me, I'm Diane, says of this organic compound. Why Diane? Two double bonds. And this one said, I am triene. Okay, why triene? Because we have three double bonds. Okay, so once again, thank you very much, guys, for watching and listening to this video. I hope that you were able to learn and have fun in this video. Okay, now do not forget to scan the code, the QR code, and answer the uh, online class survey. Okay, again, do not forget to scan the QR code to have the online class survey. Once again, this is Sir Mark. Thank you for watching and have a nice day.